before we get to question number 2, something that's really going to help you from changing from entire radicals to mixed radicals and vice versa is and we're going to make a powers chart here. You need to know your perfect squares, your perfect cubes. If you're simplifying a fourth root, you're going to need to know your perfect powers of 4. So what are our perfect squares? I mean, you can always list 1, but 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 10 squared is 100. Those are our perfect squares. You need to know those numbers and be able to work with them quickly. Perfect cubes. Well, of course there's 1, because 1 times 1 times 1 is 1. What's the next perfect cube? 8. 2 times 2 times 2. 3 times 3 times 3? 27. 4 times 4 times 4? 64. 125. Usually that's as high as you would need to know. 6 times 6 times 6 is 216. You can memorize more if you'd like. 7 times 7 times 7 is 343, and so on. And most of the questions your questions won't go beyond that. And same thing with perfect fourths. You get 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. And usually that's as high as your values go for that. But if you want 4 times 4 times 4 times 4 is 256. And 5 times 5 times 5 times 5 is 625. 6 times 6 times 6 times 6. There you go. So having these values becomes very important, especially when we're going to be writing things as mixed radicals. So for part A, yes? Ready? So if in part A we want to write something as a mixed radical and it's a cube root, what they're wanting to find out is, can you pull out any perfect cubes out of here? Because it's a cube root, we would be looking to our perfect cubes. Do any of these numbers divide 16? Do any of those numbers divide 135? Well, 16 is the same as 8 times 2. And 8 is one of our perfect cubes. So we're going to write that. It's going to be negative 8 times 2. 135, it doesn't divide by 8. Does it divide by 27? Yes, it does. 135 is 27 times 5. So what we're looking for when we're changing something as a mixed radical, we're looking for those perfect cubes or perfect squares that we can pull out. Because what is the cube root of negative 8? Negative 2. And you would be left with a cube root of 2 inside. What is the cube root of 27? 3. and you'd be left with the cube root of 5 inside. So we can write this is a mixed radical, or we could write this as negative 2/3 and write this fraction inside as a cube root. So that's a mixed radical, and a mixed radical will always have it so what's left inside the radical is as small as can be. So you can't pull out any more perfect cubes out of that number. Part B, when you're writing a mixed radical as an entire radical, what we're going to do is we're going to write the 3, in this case, as a 4th root. We still have 2 over 27 here. So if I'm thinking 4th roots, I'm going to my powers chart and I'm thinking perfect fourths. And since 81 is 3 to the power of 4, that would mean that the 4th root of 81 is equal to 3. The negative still has to stay outside because you can't take the 4th root of a negative number, just like you can't take the square root of a negative number. In fact, you can't take any even root of a negative number. Because what a 4th root is looking for is what number times by itself 4 times makes 81, and that would be 3, which is why we could change 3 to the 4th root of 81. Now, if we wanted to multiply these together, it would be like multiplying fractions. I could make 81 over 1. And how do I multiply fractions? Multiply the tops, multiply the bottoms, and you would get negative 4th root of 162 over 27. And then you would check, can I reduce that fraction? Is there a number that you could divide the top and the bottom by? You could divide them both by 3. Does everybody know the trick for dividing by 3? How you can tell right away that 162 divides nicely by 3? If you add them up, 1 plus 6 is 7, plus 2 is 9. And if the answer you get when you add them up divides by 3, it means the whole number divides by 3. That only works for 3 and 9. Yes?
162 over 27 is equal to 6.
And it's equal to, if you reduce it all the way, it becomes 6. Okay? Sometimes people see in fractions that you could reduce earlier. 81 divided by 27 is 3. So if you had reduced these fractions earlier to be 3 over 1, then you would just have 3 times 2, which would give you 6 as well. Again, the negative has to stay out in front because you can't take the 4th root of a negative. With a cube root, you can have a negative inside because a negative times a negative times a negative is still negative. Okay. These ones you have to practice a little bit. So I'll give you some time right now to try some. 3, 4, 7, and 8.